Ready? All right, let's go. So, primitive balance true recommended balance operations could have issue meta issue body outputs result could not be determined meta issue body. Okay, so these things are mad at us right now, and we had opened the df base file, which I'm going to close right now. And this one that we're looking at is oh fuck, I just made a new file. Its name is a quote. All right, this is recommended community standards overlay Alice operations GitHub issue. There's no overlay actually. That's not okay. So the path is entities Alice please contribute recommended community standards Alice operations GitHub issue. Okay, so. And what we did was we made these things output operations, and we added this collect one in. And this collect one was going to give us a list of other ones. And then, okay, so meta issue body. No, okay, so that's not what it is. That's result. Okay, so it's mad about the result. Okay, so let's take these stage outputs off, and let's just go back to basically what was there, and we'll comment this one out. And let's see what happens, right? So let's eliminate one variable. Okay, so path, all right, 234. So not this file. Path, all right, fuck, okay. So we have run into the dreaded unification of types problem again. Okay, so there's yet another place where the types aren't unified, and this is exactly why I was probably so stressed out, because now I'm not anymore. Okay, so all right, it's all fine. Okay, so recommended community standard contribution name tuple. So what is this name tuple, and why did I switch from data class to name tuple earlier when I said, oh, but we can use the name tuple stuff? Maybe it was because I was gonna hit this bug. I don't know. Maybe let's make it a data class. Data class. I think the problem with this is that we don't have a serialization for it. Yes. So the spec on the export of the import object fails. So let's do read dfml df types, and let's check out, where are we here? Def export. Okay, so so the offending line 339 in df types. Okay, so this thing here is this line, this field defaults only exists within the name tuple. It doesn't exist within the data class. So what we should do is all right, okay. So I mean, what we should do is all right, so what we should do is we should export spec as a spec should be manifest in the schema. The spec is the manifest. Yeah, the spec is the manifest. Spec is the manifest. Because this tells you how do I reconstruct this type, and a manifest can be used to describe the construction of a type, right? So thinking of a DID method, right, essentially as the init method. So exported spec, exported dict. All right, so let's see, how do we make this? Because I'm not satisfied. I'm not satisfied with just throwing. So what we could do, and why I haven't done it, is I want this to become what it should be and not to become the half thing that it is not right now, because it's time for this stuff to change. So, all right, so okay, so I think it's a config dict, which is the stuff that we just did. Let's look at the log. Okay, traverse config set. Remember this patch? Actually, you all didn't. Maybe this is the one that I was like, forgive me because I didn't write it. Okay, on screen. Okay, that's right. Okay, maybe that is what this is. And I don't think we ever properly went over this, so I think I got distracted with something else. So basically, what we did was we came in here and we said, just did a little refactoring to this to make the class name dynamic, because then we're going to take it from the list. And then we go in and we add one that's like, hey, Alice, should I contribute? Because we were going to add, because I don't have time. I want to make sure everybody can do should I contribute, and everybody can do please contribute, right? And hopefully, if we have docs on should I contribute and please contribute, that's a single action and a single response. And then one is safe mode, one is not safe mode. And so because should I is more of like collect the data and please contribute. So please, the please family of commands will be like, hey, please do something. The should I is, I'm asking for your recommendation. And then we'll have other ones, but we'll try to keep it sort of natural languagey. And obviously, with the overlays, the CLI is just like one interface, right? So we'll plug and play stuff. Okay, so all right, okay, so yeah, so we added that, and then we basically said, okay, we formatted the file with black because apparently it hadn't been formatted, and then we refactored out the object to operations stuff. So basically, this function that was here within the Alice, our entities Alice CLI, we pulled that object to operations functions out, and we put it in dffml util df internal, and that was the move to own file. Okay, so then we came in here and we just real quick hacked in the collector data flow within the inner source operations, right? So remember we did the tutorial series on the inner source stuff. It was back in like December or something, with the SAP in where we build off the SAP thing. Actually, I can show the docs now because I realized the docs for the main is working, right? So this docs is working, I realized. So where was that? Yeah. Okay, so there's this SAP thing. Oh, and are the images going to the right place? Okay, well, that one was already pointed at SAP. Okay. Okay. This is this image. Okay, this is just okay. Never mind. Okay, well, I don't know. I don't know if the images are working or not. Well, let's go to contributing. No, okay, they aren't working. Why aren't they working? Okay, no, so they didn't get rewritten. Why didn't they get rewritten? Oh. Oh, because then I started erroring out. Oh God, that was dumb. Okay. Okay, so but anyway, so here's the software portal demo. And once again, this builds on this talk here. And where are we at here? We're talking about, okay, yeah, so this is basically, it's an alternate automating classification, but using SAP's inner source portal, right? And then we talked about how we're going to do some of the stuff for the build tree org with our, our mentors who have now gone off to start their own org there. So, all right. So Yeah, okay. And so the collector flow and the collector terminology is because of the living threat model stuff. And John Whiteman it really drove a lot of this living threat model stuff. And I worked with him, and you know, we're seeing where this stuff goes. And so with Alice, we're going to feed the living threat model, right? And so that's what we're going to do with our should I contribute. Is we're going to feed the living thread model, and with our Alice please contribute, we're going to take action on the analysis that we do based off of the should I results. And we may trigger you know, people to manually do those actions, or we may have Alice do it in an automated fashion, right? And so there will be, the code will be, the living thread model will be Alice. Okay, so it all wraps up into one thing. It all wraps up into the same thing. Okay, so directly include Alice. Okay, so this is basically just doing that same overlay load, which you're seeing here, which we already did for the recommended community standards. So this is our second top level command. So Alice, should I contribute? So now that we have those two things, and we have the ability to load basic overlays on them, which are really just the whatever auto flow does, data flow, DFML, DF types, data flow, auto, and then the auto flow keyword argument there. Okay, so this auto flow here, right? So, okay, self.autoflow. So there's an auto flow operation, right? So this auto flow operation, what this does is it goes and it looks at all those definitions, right? All the different operations, and what their different, what their inputs and their outputs are, and their conditionals are, and it links them up into this internal structure called the flow dict, right? So the dictionary, because all the mappings in Python are called dictionaries. And so then, yeah, and this like the suffix prefix with the type name is another thing that I've been playing around with when we think about like refactoring and getting into automated refactoring, because you can really start to look at, if you start to name types based on a certain convention, you can then begin to pull out structures. And so we'll have Alice do this. She'll infer based on like you know, the patterns of usage of different variables, which ones really are sort of about the same data, and then name them appropriately, and then create structures out of them, which is exactly what we've just done, right? So we'll do this automated refactoring process eventually. So so it links them up into this flow dict, and it throws, what is that? What is that? What is that? Seed conditions. Okay, that's the origin. Okay, that's fine. So, and then the origin concept is that whole, you know, where does this thing come from? Okay, so basically, yeah, so we gets included in the auto flow. So now we have the overlays there. We have overlays on both of our key entry points, should I and please contribute. Should I contribute and please contribute. And then we went through and we fixed this one, and I think we just did this one together. And this is the auto import use variable names instead of generated names. Okay, yeah, so this is the init py problem. Okay, and then, yeah, okay, so we might have done this one together. Yeah, we went in and we, or did we? Yeah, the problem here was basically that, yeah, the name was not the same. And then the problem here was that we need this little helper for these config dictionary things, and that's what we're using right now, is these config dictionary things, right? So the format for those is, let's go to the docs site. The format for where is it? So there should be docs. I know there's docs on this somewhere. this in the notes. Okay, so what are we doing right now? So input or definition dot spec is in type loading information is, so what are we doing and why are we doing this way? So YAML. So if you saw the YAML, by doing it this way, we're sort of by separating, we separate the config structure from the initialization of the object, because the initialization of the object happens on a-inter, and therefore we can apply the overlays and we can apply, you know, any sandboxing that needs to happen. So we effectively end up with like this, you know, this loadable. It's like the YAML. It's like the YAML Python function calling stuff that is a vulnerability. You get the same functionality, you get it cross language, and you get it by doing this nested config structure, right? Because then you can and you get and by accessing non-entry. Okay, so definition spec, at least let's hope, because or else this is going to be not fun. So that's what we're about to find out. Okay. What is it, 1400 when we started? Okay, it's like 1430. Okay, and what is this called? All right, okay. Type learning information is limited to us built-in types. Currently, we need to move to plugin / config dict style serialization within leveraging, where was that patch here? We're leveraging traverse config set. Recently changed in case. Oh, was that why we did this? In case we. Is that why we did this? Future patches will use to create an output operation. Oh, that's not even why we did this. Oh, yeah. Oh, okay. Let's make a note of that too. Which is for future patches where we'll create an output operation which serializes the graph of inputs within the input network to a JSON, to a dictionary. All right. And then that's what we're going to take and dump to, you know, we can, this is what we can then take and import to the Web5 space for our data lake. Right. Sweet. Okay, we got an extra bullet point, but whatever. We'll probably have another bullet. Okay, so where are we now? All right, so this thing's still in flight. And what's happening over here? Hey! Oh, did I remove? I removed the... Wait a minute, what happened? I just removed it and then it worked. Okay. Oh, because it didn't try to generate the spec. Okay, so... boo. Okay. Okay. No, this is fine. I mean, it's good. It's good. It's good. It's good. It's fine. What happens when we do data class? I wanted to debug, apparently. Apparently, I really wanted to fix the bug. Okay. Okay, great. Okay, here's the bug. So, yeah, because or else it basically just says, oh. Oh, yeah, okay, just get mad. It's mad. And, okay, so why can we do... So why can we do... why is that? Why can we do data class? Okay, export dict. Okay, spec. Okay, so it must be saying, it must be trying to create, I think op must be doing it. Yeah, it must be op. Where is it? Okay. Okay, no. Okay, so what is happening then? Okay, so if you set that as a data, if you make it a data class, if you make it nothing, it just says you can't do that. If you make it a named tuple, it blows up because it wants to represent a path. Okay, what if we make that config? Or let's just make it a data class, right? We should support regular data classes. All right. And so what do we do here? So all right, export dict. All right, so how could we do this in such a way? I think what we could do here is say, plug in export spec. Okay. I'm trying it with a bunch of different types. Okay, so okay. All right, let's try. I think it might work. We'll just see where it takes us. So Okay. Okay, so if is instance all right, our good old friend raise not implemented error. When in doubt, raise not implemented error. It's a good thing. It's better than implementing it wrong. Then it lets somebody else know, if you want this functionality, here's exactly where you insert it. So, okay, so not implemented error. So basically, attempt conversion, if you fail, raise not implemented error. So if not spec, ugh. Okay, subspec is meant to denote when the top level is a list or a mapping itself. Or I think, yeah, is a list or a mapping itself, yeah. And then spec is treated as the interior type. Okay. So export spec. And I think that's determined based off the primitive. So if the primitive is array, then, or the primitive is mapping for a dictionary, that will be stored in the primitive value of the definition, and then subspec and that are used together to determine whether it's needs to be converted from an array or from a mapping, with spec as the internal type. Okay, so if is elif is instance, okay, so this is named tuple. Right, that's what we've got right now. So, and then we'll put down here, self.spec is of unknown type for export, or unknown how to export self.spec. Okay, let's see. Is instance arg2 must be type or tuple of types. So what's named tuple then? You're not a type? Super. Let's just do tuple. Okay, so unknown how to export class get repo spec. All right, let's see what's up with that. So feature get dfml feature get definition feature definitions get repo spec. All right, name tuple. Okay, elections.name tuple. I bet it's, I think, typing. Typing just inputs collections. arg2 must be type or tuple of types. All right, let's go find out why. So named tuple. Ah. I think I've tried this before. Ah. Okay. We'll just do Okay. So what am I doing? I am saying I'm removing our if is instance check, and I'm adding a check which says um, okay, so for all, okay, so elif all of these things. So if the spec has all of these attributes, qual name, annotations, field default, then export dict, right? Okay, so, but we're not going to do export dict. We're actually going to do something else internally, and we'll say for key in that array, and then that's a nested array. Okay, so, oh. Okay, unknown how to export recommended standard, community standard contribution. Okay, so it knows how to export that now. So now let's see. So git diff. So and wow, really? Did that take me to write that wrong? Okay. All right. So I'll have to add this dfml df types file, diff staged. All right, so this is what we've got. So we modified this a little bit, and we basically just said, you know, we're going to raise exception if we don't know what to do with this thing, right? So we're going to do, we added some input validation rather than just blindly doing it there. So git commit, or actually let's run the auto formatter on that. Okay, so that's what I was worried about. Okay, so the auto formatter picked up something else. So, oh, shit. Yeah, I need to go run the auto formatter on everything, actually. Okay, let me make a note of that. Okay. Run auto formatter on every commit in ours. Okay. Okay. So actually, we might be getting close to this one. This dataflow.export. Okay, because this is where we're reaching towards the same stuff here. Remember, so the config dict stuff and the manifest stuff are going to combine. Remember, it's all going to combine. So the so we're going to have the init function have include a like the schema reference for the config dict of the object being created, and when we do that, we have the init function. Okay, so we have the init function. Okay, so when we do that, fuck. Okay. First config set, data flow export, schema. So there's something here. Dot export. Okay. Exported. Okay, so when we return something from exported, when we return something from export, it should be an object which is a manifest. So it should be, the unified config, the unified, what was that? The unified theory of config, unified theory of configuration, or the unified configuration methodology or something. Saksham, you will probably remember this. You'll probably remember this. There's when we did, oh man, where is that? Okay, well, it doesn't matter now, but basically what we said was must be, this is, yeah, oh, this must be where that, yeah, this is where this came from. Okay. Okay, so effectively what the hypothesis was if you have three fields, you can oh, it's the same thing again. It's the upstream, the overlay, and the orchestrator. Okay, the upstream is the plugin, the overlay is the config, and the orchestrator is the sandbox, which is the schema, which is the archetype. Okay. Okay. That makes sense. Okay. Okay, great. So let me read my notes on the archetype real quick while we're at it, because I think we figured this out. Let me put it to do, and then let's do it. So okay, so archetype. Okay, so we'll cover the archetype. But okay, so the archetype is a construct for data. So the archetype is a mental construct to help us understand when data is aligned to a particular set, a system context of strategic principles. And we'll put perhaps an overlay. In part, or completely overlaid. Okay. Okay. Overlaid. Okay, so that's the archetype. Okay, so, and there's more notes on that, but actually I think I'm not going to do that right now. So, Okay, so the unified config theory. Where is that unified config stuff? It's on a branch somewhere. Base instantiate config theory. Oh yeah, I started. Okay, so it's 3 commits ahead of whatever I was looking at. No, no, no. Okay, no. All right. How's the CI? Failing still? Still hasn't picked it up. Okay. So, all right. So, okay. Oh yeah. So let me just write this. Yeah. So the unified config technology. Okay. Plugin. Config. What was the other thing in the other one? It was plugin config. What is it? Where can I find it? And how do I know it is conforms to that? So yeah. Okay. Okay. Here's the upstream, here's the manifest. Okay, so the manifest is therefore also sort of the open architecture. Oh yeah, because the manifest is when the open architecture is a one level thing. It's like the spec versus sub-spec, okay. Okay. So that means we should be able to store anything in this format. Okay. All right, let's do it. So this is the assertion. So then we should do it. We should follow through with that then. Okay, so export. Okay. So this thing will basically say this is where it's a DID as well, because then you would add the DID in that and the DID doc. Okay, so the context. So the DID doc would be the upstream and the DID would be the overlay, I guess, in that context. It doesn't really, I mean, it doesn't really matter. Okay, so, okay. It's like it's all right here, but it's like, it's so close, it's so close, okay. Okay, so what are we running into? So let's deal with this problem at hand. So, and we'll move towards that, and then I think we'll end up there. Okay. Okay, so what am I, because I'm thinking right now, I think this input, stuff will lead us to the right decision with the data flow export, because I'm debating every time you call export, do you really want to know what the data is? Like, do you really want the nested structure every time? I think the argument is yes. The argument is yes. That's the argument of the manifest. Is, hey, let's all just agree that we should put all this stuff in every blob of data. And if we always agree that we can always put all this stuff in every blob of data, or we can figure it out by context, then we should be okay. In this case, context would be the parent object, right? So the parent object has the context. Now I have two. The parent object has the context, and so the parent object should decide whether the child needs to be wrapped with schema and plugin name. It might be explicit within the manifest contract what that data is. And therefore, the schema to validate it lives within the manifest itself and should be pulled or sourced as a reference from the schema of the object, which is internal. So this is kind of like our subspec stuff. So, okay, come on. Okay, come on. Okay, come on. This is kind of like the subspec stuff, the context, the parent. Stream of consciousness, folks. Okay. Live. Okay. Remember, we're going for stream of consciousness. Okay, so if I were to make a next move, what would I make? What would my next move be if I had to make a next move? Well, I would write down what I just said before I forget it. And then that will lead us to the next step. Okay, so when in doubt, write it down. Write down everything you know, right? This is the methodology. The methodology is enumerate everything you know, enumerate of the things that you know, which ones are processes, which ones are assets or processes which you could interconnect, enumerate all the possible interconnections, all the possible graphs, right? And then do a tuned brute force to find the best solution within the given time frame. This is the methodology. Okay, so what do we know? So let's write down everything we know. Everything we know. What is the methodology? Okay, and then let me write a little note here. And this is in the thread, but enumerate everything we know. Determine which are assets and which are processes. Okay, so using tuned brute force, prune the trees based on strategic principles And remember, the strategic principles are the very top level strategic plans. Okay, and these are the top level conscious. We're also thinking of these as conscious or conceptual layers, or maybe even layers in a neural network. And these are the strategic plans, which are being overlaid successfully. So basically, anywhere. So where's our giant graph, right? So where's the giant graph? So where's the giant graph? I swear there was a giant graph. No, not in there. Okay. I swear we had a graph for this. A flowchart that we were working on. Where was it? Okay, whatever. Oh, it's here in the contributing. Okay, this. Oh, great, it's horrible. Okay, fantastic. Not helpful. Okay, anyways, you see this, right? So, and you can sort of make out here how there are different layers, basically, as we move through. And then we're going to have the stages, right? And so if you had, what we need to do is we need to link up the stages that we just created that we set to output. What we really need to do is do something that's more like that shim-based approach where we say next phase, right? Or the next phase parser, right? And we really just mean to say, call this thing after everything in the last phase has completed, right? And so that will because what's not shown in this diagram, I think, is output operations and cleanup operations, and those are the successive stages, right? So we need to have this rolling. Okay, we need to have this rolling stage, this rolling set of stages. This rolling set of stages. Okay, we're gonna have this rolling set of stages, and yeah, and then it just rolls. It just rolls forever. Okay. Yeah, you just keep rolling. You keep rolling. You keep rolling. Okay, yeah, and in each stage you could potentially add another stage. How could you potentially add another stage on the fly? How would you add another stage on the fly? Would you? How would you add another stage on the fly? You need to communicate with the input network and the operation network. You need to trace through the code in DF memory. You need to see gather inputs in the dispatch operations. You need to see where the data flow is used. And you need to be able to recommunicate a new data flow and update to the data flow to all of the network components within the orchestrator that the orchestrator uses. So the lock network and the redundancy checker and all of this stuff, anything that might use the data flow, it needs to have a refresh on it. Okay, and that would be able to signify that there's a new stage. But what about the rolling through? That doesn't seem like. So if it's rolling, why can't it just roll back? Can it roll back into itself? It should be able to. So from that perspective, you have different entry points. Yeah, you're different in a given stage. You may have different inputs from different origins, and so you could then trigger via a subflow or the launching of a context. Yeah, you trigger via the launching of a context what stage Yeah, you would trigger via the launching of a context with the input network cache swapped in such a way that what do? You do a, it's like a copy on, it's a negative overlay. It's like I ran into this problem with overlay FS recently. It's a negative overlay. You want a subtractive overlay. So you want to do it, and so because overlay application is dynamic and it's not just, and so right now what we have is we just have a pure merge, but because it's dynamic and when we do get to doing it with the apply at the runtime, which is what we're supposed to be doing, and not just combining all the operations right via the load call, which is what we're doing right now just for sake of time, we can have this overlay. We can in the overlay application remove bits of inputs from the cache of the flow of the data flow being the data flow having overlays applied to it. Okay, so here data flow having overlays, data flow we are applying overlays to by running overlay data flow and passing as an input. This is the one that actually is the real data flow that we're putting in here, this is the upstream. This should just say upstream. This should say upstream. This should say upstream. How dumb is that? Okay. Excuse me. Upstream. It's hilarious. Okay. Okay. So, okay, so now we can just pass in upstream. Oh, so now, oh, okay. Where's the code? Show me the code. Show me the code. Okay. Okay. So where is it? Upstream overlay orchestrator. Okay, so the input definition conversion by origin values, operation instance name, input definitions. Oh. Okay. That is at the wrong indentation level. Or no, it's not. Okay, it's just, okay, so this is basically, this just didn't get deleted. Okay. So load default deployment environment, input definitions list, input definitions. Okay. Inputs items. Okay. Yeah. So short names. It is going to do it on short name. So we can do upstream. So okay. So we can do upstream. So we can take the system context. So we can take a data flow. We can make it a system context as class, and then we can take a data flow. We can make it a system context as class, and we can pass it to Okay, system context upstream. Okay, so, okay, apply overlay, overlay dot deployment. Okay, overlay. Okay, so system context. Okay, here we go. Hallelujah. All right, what is the system context? The system context is the upstream, the overlay, and the orchestrator. So the upstream in this case is overlay is not none. So overlay system context equals create. So let's say create a system context to execute the overlay. All right, okay, so if it is not already, okay, no. Let's actually say, okay, so let's actually say, so overlay is class overlay, 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 apply overlay. Okay, so let's actually, so to move this into overlay.load. Okay, so inspect is class overlay, overlay is overlay. Okay, so basically instantiated if it's a class, if it's uninstantiated. So apply overlay, overlay, apply it. Oh, okay. So come on, come on, come on. All right, let's go. So, oof. All right, so let's play with it right now. Let's say, so let's ignore this. Okay, so overlay system context. Okay, so memory. So the overlay system context. So if you give us a data flow, okay, so if you give us a data flow here, so if is instance overlay data flow. Actually, let's just do if not raised, not implemented. Okay, so, and let's say data flow system context. Okay, so it's not a okay. Come on, we almost have the overlay stuff. This is exciting. All right. Okay, so then. Okay. Orchestrator equals none. Let's just do system context. What the hell? All right, what is the overlay? DFML overlays installed. Okay. And this is happening because apply installed overlays is set. Okay, so, and then this thing comes in and it says basically GTFO. Okay, so why is that? Why are you telling us GTFO? Okay, so union system context config data flow. Okay, so let's do union system context config data flow. No support for string types other than own class. Oh yeah, so you are correct. But what are you on about here? Okay, so basically, let's say data flow first, and then maybe I think it's a bug with the typing code. That does the conversion, and it only checks the first thing. Okay, let's just fix it. Let's fix the bug. DFML base. Okay, so 281. Okay, so convert value, and then 248. Okay, so if convert, okay, so if args annotation is not none, okay. Okay, possible type. Okay, class. DFML overlays installed. So is that not a data flow? System context dot subclass. Okay, so oh wow, that's ugly. Oh, oh, that's horrendous. Okay, so this is already a system context. I've got all these windows and I'm working on it. Okay, so okay, so if so if it is a data flow, then convert it. So apply installed overlays. System context. Okay, self.config.upstream.export. What is this thing? Okay, data flow being overlaid. Okay, so this is okay, so config overlay, apply installed overlays. So, the, oh yeah, didn't sleep very well. Right. So I don't like that that's the default. I like none as the default. Okay. So then whenever you define a system context, you better define the upstream. You might define the overlay, you might define the orchestrator, you might leave it up to the execution environment, at which point the execution environment would produce a manifest, which is so your schema is built out of your types, or out of your data flows, which build your types for your system context as class. And so it's implicit with the plugins that you provide. All right. Okay, so okay. So if overlay instance data flow, okay, so that's happy now. Okay, so let's continue. Apply overlay. So what actually happens here? Is anything happening here? Okay, so what is apply overlay? Overlay dot deployment. Oh, we're not running it with any inputs. That's why. So, or data flow to dict. So, preface CTX. Over there. Where is this? Give me a breakpoint. Okay. 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 So, so apply the overlay. All right, I think I'm done right now. Wow, I just took a sharp turn.